So Euler's method is used to find the value of y at a given value of x. In this case, we have a formula that we use, which is y new is equal to y old plus the slope times the step size. So we have the analytical way of solving this problem, but this is we using the numerical approach, and this is Euler's method. So actually, we are trying to find the value of y whereby the x value is given to us. So whereby we are going to use this formula, which is y new is equal to y old plus the slope, in which we can get the slope out of the function. When we differentiate the function, that function that we've differentiated becomes our slope. Therefore, we can do some substitution and get the slope of the function. Then the step size is the interval in which you move. So in every question, you're going to have your function and your step size, and they will also give you the initial condition. So let's take this question. So this question is given us that y prime is equal to x plus y. In this case, the function given to us has already been differentiated, but in some cases, the function given to us will not be differentiated. So one thing you must know is to differentiate the function. Then we will have our step size. In this case, the step size given to us is 0.1. And then they'll give us our initial condition. So our initial condition states that when x is 0, y is equal to 1. And then they are going to ask us to find the value of y at a given interval of x. So we are supposed to find the value of y at a given interval of 0.3 of x. So how do you go about this? With this, you should know the number of steps that you take to get to 0.3. How do you do that? So for us to know the number of steps that you take from the step size, you know the step size here is 0.1. So then, how will you know the step that you will take? How will you know that? How will you know the steps to take to get to 0.3? So in this case, you are going to look at the initial condition given to us, which is x is 0, whilst y is 1. So if x is 0, then what will be the next step to move? You're going to add 0 plus the step size, which is 0.1. Therefore, we are going to move 0.1. Then you're going to add another 0.1 to the 0.1, giving you 0.2. Then you're going to add another 0.1 by the 0.2, and you're going to get to 0.3. Therefore, we're going to move how many steps? This is 3 steps. So we are going to do iteration 1, iteration 2, and iteration 3. Normally, the iteration is the steps to get to the solution. So let's start. For us to get to the iteration 1, first, we need to fulfill the formula, whereby the formula states that y new is equal to y old plus the slope times the step size. So then we have our y what's new, which is y 0.1. This means that we are finding the value of y when x is 0.1. Then it's going to give us y 0. This means that we're going to take the value of y when x is 0, because that is the old um, initial condition they gave us, plus the derivative of the function. Then we are going to substitute in the initial condition given to us, that when x is 0, y is 1, then times the step size. So let's see what we do. So then we are going to put inside, because we have 1, because when x is 0, y is 1, which is 1, plus the function given to us is x plus y. So we are going to substitute the value, that's the initial condition given to us, that will be 0 plus 1, then times the step size, which is 0.1. So when you do that correctly, you're going to get 1.1. So at the value where x is 0.1, y will be 1.1. Then, because you're going to take 3 steps, you're going to do 3 iterations. And the second iter or iter 2, what are you going to do? We are finding the new, which is 0.2. Now we are going to find the value of y when x is 0.2. Then we are going to take y old. In this case, y old has been changed, because from the previous one we had the initial condition, but now we've gotten another condition that states that when x is 0.1, y is 1.1. Therefore, we are going to do some substitution here, because y old is now at when x is 0.1, then you're going to get 1.1 plus. Now, the initial condition has been changed because now we are using what? The y old condition, which means that x is 0.1 and y is 1.1. So then we'll do the substitution into the function which we've differentiated, then multiply it by the step side. So when you do that correctly, you're going to get that 1.1 plus bracket open 0.1, which is the x value, plus 1.1, which is the value we had when x is 0.1, then times the step side, which is what? 0.1. And when we do that correctly, we are going to get 1.22. Well, guess how can you solve for the last iteration? For us to solve for the last iteration, I want you to try that and note the answer that you get must be 1.326. That is 1.362. That is the answer that you must get. I hope the video is very helpful. And if it's very helpful, please kindly check the subscription button and subscribe for more.